welcome to the stream if you're watching this in the future. I'm just gonna set up the chat. Since it's necessary to reset that every time. Let's see, and if I interact here, we can change that. Let's see, CSS style margin. Top right, bottom. Let's try this. Doesn't matter too much. Okay. Uh, let's see. Clipping, CSS, body. I can't remember my CSS. That's alright. Okay. Let's try a clip path then. Uh, let's try this. Well, it doesn't actually change anything then. Oh, I need to do inset. Or what? Doesn't change anything. Content books. Well, it doesn't really seem to change anything here. Mm. Uh, hmm. Is it not possible to set that up? Mm. Maybe not. Oh well, I'm not gonna waste too much time bothering with that. I would prefer for the chat to be different. Uh, whoops. Did we miss the link or? Uh, maybe, maybe change the link. Let's see. Nope. Did I change something here? I must have 0 pixels auto. Okay. For some reason that needed to be set. Anyway, okay. I'm not gonna mess around with the chat. Okay, let's get going. So today I wanted to mess around with the UI system so that we can build a text box so that, for instance, we could select an item and edit the properties of that item. Yeah, so outline for this episode here is to implement something like a text box with editing. So we will work on that. Then we will fix the scroll bar issue, and then we could look into implementing a non-reallocating container instead of vector for data structures that shouldn't reallocate on resize. And I've found an interesting article here that would be the backbone for such a data structure. So since I'm suspecting that the use of the standard library vector is sometimes problematic in a system like this, where we don't want vectors to kind of like move all our objects. Such an allocator, not allocator, such a data structure like this would keep the pointers intact and wouldn't move objects around. The only downside to them would be that all elements wouldn't be exactly continuous in memory. So we probably wouldn't use it for everything, but um, we could use it for something that um, isn't supposed to be highly continuous in memory, but only needs a certain needs certain subsections which are continuous in memory. For instance, our UI here would have windows registered in a somewhat continuous part of the memory where we would like to access it by using pointers and handles. So maybe we should create a system for that. I'm not sure that our vectors of different structs should be converted into such a system. I think instead uh, it's probably better to allocate a certain chunk of memory for general data storage, and maybe when we, if we in this series here decide to optimize our code and get a bit more juice out of our system, um, we would do some data storage and manual memory handling. That would be a way to optimize the code, or rather data flow through the program. But yeah, that's way out in the future. Right now we are still on a single thread performing in the area of 3500 frames per second, which is even though we are spending a lot of time in unoptimized code doing the UI, it's pretty good still. All right, so the idea is that we should probably have some a way of editing a specific item. It should pop up with some text field that is editable. not editable, but edited. Yeah, that we can change the values of. Um, so that's the hope for at least this part of the session here. So I imagine that, and then we will also fix a better font with bordering, proper size for text fields. So let's see, using our program here, Hero or Hero, I don't know. We could create an outline which has a black color, for instance, or a green color. Let's see, outline. Oh, whoops. We would have to change this white, and and let's do um, 0.1. We could change this to green so we can actually see what we're working with here. Join. Anyway, we would like something like this, of course, with a black border for our font. We would probably also like something like a smaller text size so that characters look more appropriate when we scale down our UI text. Uh, yeah, and we would scale the texture appropriately, but yeah, that's the idea. So we will need that, otherwise we can't see our text when we're editing it. And we will probably like a bordered text anyway, since it's probably going to look a bit better, be a bit more readable. And so we will fix that as well. Okay, but we need some kind of new control for our UI system here, which will be let's just give it a bool for now, a text field where we pass it a context pointer, context. Um, and it will have a const pointer text buffer, which will have a const unsigned int text buffer size. And then we could set some sort of like const vec2 a reference to a size, which will be set to our vec2 standard size here. Okay. Also, I would like to play around with the performance of the std string compared to simple const pointer buffers. So that's the general idea here. Let's see. Yeah, so I think we should start by calling the method, of course, text field. And we will pass it our MP editor context. And we need a const char pointer test text buffer, which will be set to our test value. And we will pass it our buffer here. This is at compile time. Since we're right now not working with dynamic values, let's just do a count. Array size, is it that? Let's do the count. Oops. Maybe. This should be compile time, right? Let's see. Const char minus size. Runtime. Okay, we can use this string length. We could also create a yeah, we might want to change that eventually. Whoops. String length. Text buffer. And we won't pass any size. So we create that. Let's simply copy our button method here. Let's close this. We're not going to use that one for now. So let's clean up our button code here. We can simply pass it the text buffer here. Although this might change the handle. Yeah, maybe we want a caption as well. Let's do a string reference label, which will be our actual label for the text field. also as a way of naming our control here. So it will have a appropriate handle. Yeah, I should rethink this. The position is fine. Mm. Well, calculate text size. Do we have one that is not bounded? Let's see. Let's create another function here. Unbounded, where we don't pass in the max size. We don't pass in the indices here. Clip rect. Do we even use that? It's probably an old version. Let's see, help us not needed, is mouse overrect, blah blah blah. Is item pressed? So let's go to the, whoops, what? It's definitely not. Figuring out where to put it, I think IntelliSense has burned out. It feels like it has too much work to do. Let's see, did it put it up here? Whoops. This one. Create context, update. It didn't really create. It's adding some clip rect function instead. Okay, let's just copy this and rename it. Yeah, IntelliSense really doesn't like the what do you call it? We don't. Oh, the X of course is needed here. There we go. This is a simpler version that doesn't clip anything. It just calculates the size. Yeah. Okay. We can do an unbounded call. This will be deleted. This will also be deleted. So we have our handle, our position. We do some calculations. Let's disable this. We add a bounding volume, a text color here. It's temporary, and we return pressed. Let's see. We need to fix some errors apparently. One failed. I should really suppress some of these warnings. Warning, okay. Did we? The warning, warning, warning. Warning. Error. Doesn't take 3 arguments. Well, no, we forgot the label. Test field. Okay, we have our test field here. Let's do a traditional white color for the text field. And we don't need hovering. Whenever we click it, we want some behavior. Well, let's just say that we want a field size here, which will be 50 pixels times, well, 25 pixels. Okay. The whole bounding volume is, let's see, do we have any helper functions? Advec. So if we add the position and we add the text size and we inside that add vec, add our field size. Well, no, we shouldn't do that. Since we want this to be the same line, let's see, plus field size dot x, okay. Yeah, okay. Let's do some bounding volume recalculation here. Bounding volume minimum is equal to the position. Bounding volume maximum is equal to add vec position text size. And then bounding volume max x plus equals the field size dot x. Okay. This will look weird because, yeah. Let's draw some text first. We will do our label here. Our label color, which will be, let's just do black for now. We will change this in the future. Label color. Let's try drawing that. So our test field here, and then this is the total control bounding volume. Since we have a label text, we have a text field. We will have a vec2 field pos, which will be equal to position, and field pos dot x will be and we will create a rect field bounding vol. Let's only do this if we actually so this is needed, but this is not needed. Hello. We will do it only if the thing is supposed to be rendered anyway. So we will set our field bounding volume minimum to our field position, and our field bounding volume maximum equal to well, that can be a troublesome transition. And let's do the field size here. So let's see, we have a field now that we can draw using our bounding volume here. There we go. So now we have a test field, also a caption, which is nice. Now we need some behavior. Also, I wanted to we want to add some input information. So, because right now we can't capture keyboard input. We save some button states here between frames because we might use them for specific input, but we could simply add them to a frame-based buffer. That would be some sort of input queue. So if we allocated a savable key states, we basically only want the key. So maybe we just want some unsigned ints. So if we do unsigned int pointer, key q, which will be a null pointer, and a key q index, which will be null. Then at initialization time of our input system here, we can do an allocation. So we could set our key queue to a new unsigned int array here. And let's see, do we define our input? Yeah, define input max key captures, which will be 15. Well, I don't think we need that big of a memory allocation actually, because per frame we are probably not going to catch whoops, that many keys. And the idea is that we simply reset our queue index each frame. And we of course need to deallocate our queue here. Yeah, transitioning into a precompiled header setup can be difficult once you get set. It's probably easier just to make a new project with precompiled headers and move all of your files individually into the project and adding them to the project. It depends on how much time you want to spend on it. Well, so right now we have a buffer that is able to store 10 integers per frame. Oh, okay, yeah, that can be difficult also to figure out. So we don't want to process our mouse state, but we could do something like if the key state was down, we simply did you remember to include the precompiled header in that specific CPP file and set up the correct settings for using precompiled headers in here? Need to do that for every file. So if the key is down, we could simply pass the key value onto our buffer by setting the key queue, key queue index. Now you should set your project up to do precompiled headers. Okay. For all files, you can't do it on a single file basis, as far as I remember. So we do like this. If our key queue well, let's just check that first. If our key queue here is lower than whoops, that's not the file. This is the file. Is lower than, and the key state is down. We will add it to the buffer. So now we will have a key queue. And we should well, how do we expect to iterate over it? Well, do we just get the pointer and then let's see, Win32 key ID virtual key codes. There it is. So there 0 would be not set, it seems. So that's great. That means that we can simply use the pointer. We could use the max here as a limiter, and we could break the loop whenever our system gets to the end of the array, or whenever a field is empty. So we could get an unsigned int pointer here. Get key q, static inline, of course. Key q. Return the key q. So now our application here can actually pull some information from the input system. So for instance, if I pressed a lot of buttons, let's do something like input system. Get key q. We could do something like for int I is lower than. Let's see. Let's just save this one. Whoops. Let's ref and okay. Key q pointer. We will simply store this temporarily. If the key q pointer I is equal to 0, let's print out 0 val. Otherwise, we print out val, and we cast the value to this. I'm not sure whether I should dereference this. It probably would be the case, but let's see. Yeah, so right now it's garbage values. So let's dereference this. Okay. It won't allow me to iterate over that. Let's see. So we have garbage values here. 0 val. Let's see, print and passed to buffer. So We do not get any registry. Oh, yeah, we do. It's just too fast for us to actually uh, be able to capture it. Pass to buffer. Okay. Let's see. Unlock 0. And we do like this. So if we ever grab some keyboard input, well, right now we're not getting anything. Oh, wait a minute, we're not assigning the key state, of course. Okay, that makes sense. Okay, let's see. Uh, and we could do a static inline unsigned int here where we get key queue size. Well, sometimes IntelliSense here is not my friend. Okay, so instead of doing that, we do input system get key queue size, and now we should be able to write out our buffer information. Yeah, as you can see here in the background, I am able to uh, parse out our information here. Which is pretty fine because now we have a queue, sort of a buffer where we can sort of a buffer where we can pass out some information here. And of course, our keys here will not be directly translatable into char. So we need to probably do a bit of parsing. Let's see, so the 0 stuff here, network, the letters also worked. But we are all the key codes period. Yeah, period and comma needs to be handled since we want to support that. So maybe we can do some interval checking here. Let's see, is there a fast way conversion from Win32? Nah. Well, we already know. So we could simply set up some bounds here. So our zero key here will have our lower bound. Zero key. Whoops. And let's do a 9 key. And then the A key, A key, and then the C key here, C key, and then probably let's do a right shift. Play, blah, blah, blah. Pause key, backspace key. Key Q pointer, I equals this, hit return. Okay. Let's see. Well, it doesn't. Oh, backspace. That's not the key. Enter key, of course. My mistake. Yeah, there we go. So if the let's set up a bracket, check if it's inside the if it's inside and let's create it maybe another bracket section here. So we will check if the input key is equal to or higher than the lower key here. And if it's lower than this. If it's inside the primary range here, we know that we have a a letter or number. And we can lastly check whether it's unlike this field here. Also, PQ pointer here, if it's unlike. Key pressed. Well, we shouldn't get this. Oh, the minus key. Reserved. Okay. Well, we could do this check here. Let's see. Let's see, AD. Okay. We simply have some basic bounds checking. What if I remove this? Well, it doesn't really matter. So, but let's just leave it in for good measure. Okay. So now we have some input polling. And let's see. Let's do a, this is going to be the label, which is going to be specified up here. Let's set this to a field color so that we can know the difference. Okay. If the context active handle is equal to our handle here, we only do this stuff here because that means that we have clicked on it. Let's try this. So now I click on it, and then I can do whatever I want. If I click on this and press the buttons, nothing happens. So I need to click this, and then we have keyboard processing. Okay. Let's try to draw some text. Let's do a std string, written stuff. And we will EQ pointer of course cast it. And let's try printing out the written stuff at the field position. Whoops. Okay. So let's do maybe plus equals this cast as a char. Yeah, I can actually see something changing here. So this means that it now renders our text instead of our text here. Let's write our buffer. Okay, I need to increase the underlying buffer. Yeah, do I control them here? No, I don't. I probably, nah, I do it at the application level, I think. So on create, how many? Is it in our renderer? Header file. Whenever I create the buffers, reload some static data. That's not it. UI vertex buffer, GUI, max elements. So it's in here. Let's just increase this to 500 elements. So yeah, now when we do make the field active, it renders our buffer text. Also, if we inside this offset our text buffer here, let's see, we should be fine in seeing that, yeah, only the last part of the text gets rendered. So that's the way we can control which part of the actual information inside the field we want to draw. So we could do something like a restricted buffer const char pointer, or maybe just no, we're gonna change it. So, no, we're not gonna change the actual pointer itself. Let's just do an array displayed text, which will have 4 elements. Now we need an initializer. Well, there we go. We're going to change whatever we want here. So memcopy into our displayed text, and then our text buffer reference to our whatever we offset, maybe just 4 for now, and then size of char times 4. There we go, and let's just pass in our display text here. So now we can iterate by changing this, meaning that we will only display 4 characters, and the 0 terminator is included in that. So yeah. Oh, it's not. Okay. Maybe this is not correct. Might not be 0 terminated. Oh yeah, okay. And let's do a displayed text for, set that to a okay. And we will only create 3 characters here. Whoops. Whenever we do this, let's see, 0 terminator char pointer C++. Okay. We don't need to do that. So the middle 3 here, let's see, looks reasonable, even though the font is pretty awkward. But right now it's doing a space at the end. If we move this, yeah, okay. So that's a way of controlling whatever we show, meaning that we can index into our string if it's wider than the actual field. Great stuff. So now we have the beginnings of a text field. Of course, we could disable input polling and stuff like that, but we don't care about that for now. We will handle that at the application level. So if we're inside our UI system, um, we will kind of like implement a method where we will disable input polling on, for instance, the character controller or the camera controllers. But yeah, so now we have input queuing. We have a field that actually shows some information. Great stuff. So if we actually activate the text field, we decide that we want the Key queue. We store a local pointer. We parse for relevant input here, and we also check if we ever hit the return button, because that would mean that we want to set the value in the underlying field. So yeah, next we need to implement actually changing some values. So inside our UI here, we have our text buffer. Where we can edit our field here. Maybe we want this function here to return true if we ever hit the enter button, which would mean that it would, hello, I'm creating a text field where you can write stuff into in our UI here. Yeah, so that I can edit different item information and store it through the UI. So now our system has the polling, it has the queue, it has the enter detection. We need some way of handling an internal buffer of sorts. Yeah, so how can we create that? Yeah, I do. All alone. Well, the actual buffer itself is stored outside, but how do we decide to remember the information in the actual field between frames? Now that's a tricky one. Maybe we want, do we want a allocation on the controlling window? Do we want a, maybe a separate area of memory where you can do temporary buffers or different states. Well, that's tricky because the data, because we want to only change the underlying data outside of the UI system. For instance, this text buffer here, we only want to change that buffer if let's see. We only want to change, rather, let me try to redo that. We only want to change the contents of this buffer if we actually press enter. Otherwise, we want to hold a copy of the buffer somewhere inside the UI system so that we can edit the contents of whatever we load into our UI system, and once we press enter, we get the update. And we should leave the UI system, of course, and the application should know that the underlying value should be updated. I think you could do it in several different ways. I just would like to avoid everything being some kind of pointer soup. We don't like pointer soup, even though it might taste good. It will make us sick down the line. Okay, let me just contemplate this a bit. Uh, mm, mm, mm. Let's see. Mm, okay. Um, hmm. Yeah, we should probably create some state values, i.e. meaning track the current cursor offset inside a buffer, track the underlying buffer. Um, uh, yeah, yeah. Uh, so whenever we do that, um, uh, Let's see. So we need to create some kind of state. Okay. Wow. Mm. Uh, so, yeah, I'm thinking that I'm just gonna store some kind of also maybe we should add some. Good morning. How you doing, Georgie? We should probably add some. I'm pretty fine. Enjoying the weekend. What are you up to? Oh, that sounds nice. That's great for weekend plans. It's going pretty fine. We are starting to have a usable UI that will soon support text editing, and that will mean that we can build a basic level editor of sorts, where you can edit item information, create new items, yeah, yada yada. So that's pretty great. Yeah, I think it'll probably just be today, and most of the UI work should be done. So that's great. I'm just trying to figure out how to initialize some buffers. Mm, yeah, that sounds nice. I hear that it's a great engine. I haven't tried it myself, so yeah, that sounds awesome, man. Getting the right tools for the job there definitely is important. Mm, Uh, yeah, you can do that as long as it's to an official site of sorts. Oh, well, it's on YouTube, yeah. I'll check it out eventually. Let me just copy the link and put it inside a to-do list. Whoops, that's not it. Okay. Well, that sounds nice. I'll definitely check it out. Probably during some break or yeah, whatever we'd like to call it. So a way of handling this is by creating a local buffer for the current yeah, I can understand that. Yeah, I've seen some really good games created in Godot. Okay, let's see. Let's see. Let's do a struct text field data. And let's store one on our contact. Let's see. Draw position X and Y. I don't think I ever use that value. And let's just do width and height here. We will see a lot of red squiggly lines. Last frame, current frame, hover handle. Well, do we even use that right now? Active handle, active just alive, blah blah blah. Yeah, IntelliSense doesn't like this header slash CPP file for some for some reason. Text is not defined. Well, I'm not defining anything here. Function, yeah. Thank you very much, and thanks for dropping by. It was nice seeing you. And have fun with your game. So yeah, our text field data here should contain a uint64 handle, which will be set to 0. Window handling, well, this is all for Windows. Widget handling, widget data. And we will set this to 0. We will also have a clear function where we will memset at the pointer of this to the value of 0 for the size of this pointer dereferenced. At least we can implement it like that. Okay. Add initialization time. We want a const pointer buffer text buffer. Let's just do like that. Text buffer. Okay. And at initialization time, create context. We can't jump because IntelliSense is messed up. Let's see. There we go. Record window. Yeah, we do use this. All right. All right. Okay. So whenever we create the context, we also need some kind of destructor now because we will do some buffer allocations, which means that we would like to handle those buffer deallocations here. Let's create one of these. Okay. This should probably be something else. Returns where the return was pressed. Okay, let's see. Let's close this down again. So our record window, well, during our update we do some stuff here. So let's add that to our destructor here. For the context, we iterate over them. Let's move it up so that it's early in the function. Static allocations. Okay. So inside our system here, we will initialize this as a null pointer. And then if the context dot second dot text field data text buffer handle is set, that's also a reason why we shouldn't reset if it's created like that. We delete that buffer. Let's see, we might end up in a situation where this will give us some bugs since we're allocating through the map. Uh, what do you call it? The map data structure. But as for now, we're not creating other functions. So is equal to new char array with the size of whatever we decide it's supposed to have. So where should we start that? Global settings, rendering. UI, define a G text UI, of course. We need to preset things here. Yeah, I should redo this in the future. Text field buffer size, and let's do 100 characters. There we go. Great stuff. Punctuation, char. What do we call it? We call it period, of course. Let's see, what is the actual travel? 64. So whenever we create a context, we allocate some memory for the buffer. I don't know if this data structure will move it around. We'll see eventually. Hopefully the default copy constructor for a context just copies the pointer. Anyway, we create a buffer. And we can ask our context here if the p context text field data handle is equal to our handle here. Use current state. Otherwise, we want to set the underlying state. Let's see if the is pressed. Well, since we press it, we set the actives, and we don't want to do this processing here, I think. Anyway, let's see. Hello, buddy. Well, it's no problem. I'm just glad that you dropped by. Ah, well, that's just YouTube for you, but it's no problem. Uh, okay. Otherwise, we need to initialize the state, and we then set our uh, text field handle to our handle here. We the streak does not end. What do you mean? No, that's true. That's true. That's amazing, man. You are the most dedicated supporter of the channel. How's everything going? Okay. Okay, let's see. I don't know. Eiley? Oh, Yeah. Doesn't it mean I love you? Well, that was funny. Yeah, yeah, that's 10 out of 10. Definitely. So if we initialize this state here, we can memcopy our, this is the destination. Yeah, I think that was a 10 out of 10. So let's see, text buffer here, string length of text buffer. It was pretty cute. Of course, the text buffer here needs to be passed. Uh, maybe does this? Hmm. Uh, let's just do this for now. Display text. Of course, we need to set this. This is not the correct mem copy or what? Mm. Oh, it's probably talking about that one text buffer. It's pretty good. How about you? Use current state. So let's see if it registers quickly. So let's see. Initialize the state. Use current state. Okay. So this gets called correctly. What are you up to today? So we copy the buffer. Use internal. We will set the flag here to true. Uh, Yeah, you do? Have you had anything particular in mind? Okay. So we need to add to that array whenever we get key presses. Right now, we do it through a string. We could do it manually, I think. So we simply so we want to yeah, we want some kind of cursor thingy inside our text field data. So let's see, let's do an unsigned int cursor, which will be 0. Okay. And right now this is hard coded. And let's set our well, would we like sure thing, buddy. Good luck with your projects. So we now have a cursor. Right now, it just copies over the text. Thank you very much, man. Whoops. Ah. Read access violation. Yeah. It might pertain to the yeah, I'm pretty sure it's related to the map moving the pointer. Yeah. Yeah, we definitely want to deallocate that on destruction. Let's see. Let me just check that we haven't created a memory leak. It doesn't seem like it, but yeah, you never know. No, it doesn't seem like it. Okay. Let's see. So if we use the internal buffer, we copy. Oh, of course, we need to do size of char times this, because otherwise we won't be copying things correctly, I think. WV test value, test field. Huh. Well, it's definitely pointing to something weird here. It just gets garbage values now. Let's debug this. So, does our context here have a text field? No, no, I don't think so. I might. At least not to my knowledge. So this is supposed to be set. The first character. So it does copy the T. Use internal. Yeah, the displayed text. Okay, let's step into this function here. Wait a minute, let's remove that. So our display text here. Oh, I think I'm copying the memory address. Yeah, that's the problem. Great stuff. Okay. For some reason, huh? Is it this whole thing here? Is it this that we're having trouble with? Let's see if context size. Let's do this. And let's do this, maybe. Okay. Uh, let's see. For some reason, I mean, hello, man. Welcome. Is it that axis there? That is the problem. I'm pretty good. How about you? Well, maybe because it's static, the actual memory allocation of it is as they say, not great. Yeah, I think we need to change the allocation system eventually. Right now we have a memory leak. Should we ever decide to destroy our UI? I'm working on a text field here that I can write into. Um, so I'm building that on the UI. Uh, we could also write a constructor here, or rather destructor for the context. If the uh, text field data dot text buffer so we delete the well okay. It should be pre-initialized as 0. I mean, oh, maybe we also want to set this pointer to a null pointer. Maybe that's it. If we move the objects around, oh, well, that's not it. For some reason, I need to look into the memory allocation here eventually. Let's just add it to the to-do. Fix memory allocation in the UI system for the text field buffers. Yeah, it's probably because they are statically allocated, but I don't want to do the rewrite of them being allocated at runtime. So if we change this, we need to rewrite a lot of stuff. So yeah, maybe it's not smart to have well, allocations like that. Yeah, now I've written it multiple places. When we close our system, the system will deallocate the memory anyway, so it's not really a massive bug. It's just better to handle your allocations properly and make sure that you do it correctly every time. Also, if the system in the future is supposed to handle context creation, deallocation, for instance, swapping between different UIs, we would need some way of doing that. Anyway, we don't need this, we don't need this. Okay, but let's return to that eventually. So, we copy our buffer. Let's see. Let's set our unsigned int buffer size as well, which will be 0 here. And we simply p context text field data buffer size will be our string length of our original buffer. Okay, so we want to reference this, but we want to pass in the cursor position here, which means that let me just show you, when I couple this field here to this method here, it means that every time we press a button, the text field should, it should at least change, but it doesn't. Oh, it's because I didn't increment it, of course. Well, now everything should work pretty fine. Yeah, you can see that we kind of like move the cursor, so to speak. Also, we have some hard-coded values somewhere in terms of our buffer allocation. Let's see, when we create the context, we actually have a buffer size of a maximum 100 characters. Right now, at least. So we could end up in a situation where we absolutely overflow. But let's just do something like this, memcopy. Actually, I don't think we will do... Well, this will set up the buffer. This will just use the buffer. Internal buffer. If we have registered, yeah, let's just use this for now. I'll tidy up the code whenever we get done. Yeah, but right now we're in the testing phase. So if we actually use the internal, this one is already set. So yeah, what if we memcopy our text field data, the text buffer pointer, and let's call it, cast it to a void pointer here. Now a byte pointer because that's easier to increment, plus our cursor size here. Well, plus our buffer size. And we want to copy our data here. Oops. We want to copy our data. And we simply want to copy one char. Let's try that. So at the end of the buffer, we should append. As you can see, I pressed F. It didn't work exactly. The input string is, as you can, let me see, up here, test value. So let's see what works. And let me move the console so that you can see what I'm actually typing. Key pressed F, key pressed F, 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 F. We get the first F. But of course, we do not increase with our buffer. Yeah, so it means that we just, or rather cursor, so it just means that we overwrite. So our cursor should actually dictate what we're writing. So this means that right now we can actually overwrite the text. Let's see, O, W, okay, we of course increase the cursor as well, so we can actually see what we're changing. But if we change this temporarily into a 0, we will see everything. So let's see, overwrite, yeah. Let's see, does it register lowercase letters? No, it doesn't. But we can change that if we want text editing. Right now, I'm really just setting up for value editing. So yeah, now we copy to our internal buffer. Uh, yeah, so we can update our internal buffer here. I think text field key pressed. Let's keep on doing that. Let's see our application here, or rather input system here. It's just silly to iterate over all of them. So let's do instead get queue size if I already didn't. Oh, I already did. Great. So right now we increase the cursor. Let's set it back to the whoops. We can simply move this since we will be using the cursor. Okay. Let's do some backspace processing here. Backspace key. If the thing here is equal to not that, this virtual key, backspace, delete, delete this. So return, and right now we change the first value here. So we want to kind of like split the data and move it by using the cursor position. let's use the let's do something that is quite temporary here. Arrow keys. Let's do left and right arrow. If the key stuff here, key Q. I should do a switch actually, but let's just rewrite that later on. If the cursor here is higher than 0, we simply decrease it. And as well, we simply do like this. Otherwise, if the right key is pressed, cursor up, down, left, cursor right. Okay. This needs to move whatever data we have on the right side of the cursor. But let's do like this. And of course, let's just do our global here for now. Let's see. So if we activate this, yeah, we can move our text here. Yeah. Then we need a delete function. If the cursor is higher than the buffer size here, we want to so if the cursor is 10 but the buffer size is 4, we added something at the 10th slot. We simply set the buffer size to the cursor size. Great stuff. And it will reset right now whenever we click somewhere. No, it will not. It will actually store the current buffer. Okay. Let's see. If the cursor is also set higher than 0, because otherwise we won't be able to do anything. Let's just create a char 0, which will be 0. Copy. Let's see. So if we move the cursor here, yeah, it will treat it as a null termination. So we will white space it instead. Yeah. We could actually add a small cursor rect here if we wanted to. Uh, let's see. Cursor bounding volume. Uh, yeah, we need to update this, but let's do a green cursor. And our cursor bounding volume minimum will be equal to our field position as a start to our hmm, Hello, man. Welcome. Right now we won't be doing anything. Plus 0 minimum x equals to this minimum x plus a couple of pixels. Yeah, I am. That I am. Okay, let's see how that looks. We of course need to change the color here and not make it bordered. So let's see, we get a green cursor here. Let's see, unsigned int cursor position equals um, let's see if the cursor is below 0, which it shouldn't be. Well, above, let's just say 3. We set it to 3, otherwise we set it to the cursor position. Yeah, we could do some intricate stuff where we actually get the actual character position, but we don't mind. Let's see, now we should be able to move our cursor here. Yeah, it's not precise by any means, but yeah, it's definitely not precise. But that's the general idea, I think, of rendering a cursor. Okay, so we can move our text field here, we can delete. Okay. But this backspace here should then by the cursor location int I equals cursor. Well, no. Let's just do a mem copy where we actually we don't need to reset this. We just need to move whatever we have later on. So let's rewrite this. So we will get the byte pointer And we will copy whatever we have +1 here. For as much as size of char times the buffer size here. Let's see, what am I doing here? Am I messing this up? I think I might be. Let's see, let's remove this function here so that our error checking gets better. So we have our address here, which is at our cursor pointer. Then if we offset by the amount of text buffer, let's see, text field data. Whoops, I'm jumping around. Buffer size. Class type. Let's see if I delete this. It's fine. Right. Let's cast it to a size t. Oh, whoops. Of course, that's the problem. So size t times the buffer size here. And then we decrement the buffer size. So let's see. There we go. Now we have all right, great stuff. So now we can simply backspace. Right now, nothing will happen, but if we move one, we simply, oh, we need to decrease this by 1. I think, yeah, we delete the T, S, no, the E. So whatever is to the right of the, or left of the cursor. And let's do the delete. Delete as well. Uh, +1. Let's try that. So if I press the delete key, oh yeah, let's copy to, this is also, well, it doesn't matter as long as it's, if it's 0, we want to delete, well, I think it's like this. Yeah, so now we can delete whatever we have in front. Of course, mm, so if the buffer is empty, yeah, we shouldn't do anything. Yeah. Okay. We're starting to have some of the wanted behavior. Great stuff. Great stuff. Great stuff. Great stuff. So we now have our delete and uh, let's use this as a way of well, we could create a function where we simply get a float, calculate x. Well, we simply maybe want to, yeah, find font character. Yeah. So for in I equals this and I is lower than display text, string length, display text, and we increase the I. Let's do a float x offset equals 0. We do this, and do we have a, what is the name for the font? Pointer to the font here. Dot x advance x offset plus equals this times 0.5, I think, because that's our scaling right now. Okay. Mm, maybe we want. Let's see. So if we set the cursor position here, we instead do that. It's 3 characters wide, potentially. Let's try doing that and see what happens. And if we Mm, so if we simply set this to 0, yeah, we're not really getting the expected behavior here. Okay. Yeah, and this might be because we're not editing the string correctly here, but at least we did get closer to some behavior that we would actually like here. Okay, the backspace here should also afterwards decrease the cursor, I think. This should not, because it just remains in place. So, yeah. Yeah, it's definitely not elegant in any kind of way. Maybe we can do like this again. No. Uh, well, this needs to be, if it's above, above, let's just do 3. Do the cursor. Otherwise, we do. Otherwise, we do. Well, be 0 here. No. Let's try that. Yeah, exactly. Well, we could do some clamping here where you can't move the cursor outside of the current buffer range. Let's see. So now we shouldn't be able to move the. Yeah, exactly. We can't move past whatever, but we. Okay, space is not done. Space 020. So that is it directly translatable. Or key point equals vk space. So now we should be able to add some spaces here. Okay, we just overwrite it. Okay. Actually, we should do something like the opposite of this. Right now we're overriding. Right now we're in insert mode, which might be fine, but yeah. Okay. Anyway, let's do a const expression int amount of visible. Well, this is at compile time, so let's do this. plus 1. Let's see, does this still work? Yeah, and I think we can increase the amount now by just setting this flag here. No, I can't, or what? Well, the text rendering itself might not be text buffer 1. Display text. Oh, I forgot this. Yeah, so now we can great stuff. It's all right. Right now. Yeah, right now we don't have any way of adding stuff. Okay. Great stuff. Bool return equals false. And let's see. Let's do that. Since this gets set inside there, we can do something like if press return. We should set this to 0. Also, we should copy back our values. So this should, yeah, remove us from whatever function we have. Okay. Great stuff. Let's compile this in release mode. Okay, so we basically have some value editing here. Let's do a mem copy. Mem copy back. Destination is our text buffer, and our text buffer size is the amount of, let's see, where did we go in terms of the cursor here? Our sources are p context, text field data buffer, and we text buffer size times size of char. Okay. Let's see, a void pointer here. Let's see. Okay. So in our application here, we will do a const pointer tester value char equal to whatever. In our application here, we will pass in this. Whatever. Let's see if I delete that. Well, writing location. Is it because it's const? I made a promise that I won't change it. Let's see. Whoops. Char pointer. Let's do something like this. Yeah, okay. And it stores the information. Yeah, let's see. Let's delete the T here, and everything works. Great stuff. So we could simply do something like if this returns true, it means that we press the enter button. And that means that the value should be processed. Hello, buddy. Which means that we want to store our value here, and then we could do some parsing on it. Let's do a red cursor, by the way, because it's more obvious. Cursor, red here. There we go. Okay. So we copy back the buffer, we reset this. We of course need to display the text no matter what. Let's see, let's do this outside of this scope because we can then do this. Um, let's see. Label code. Oh, it's probably already initialized. Okay. Well, no data gets copied. Mm. Let's see, let's split this off into this because it's just processing of whatever we have here. Now we can click, our cursor will appear. Our value will only change when we press return. Yeah, that looks better. It will actually store wherever we last had the cursor. I think, although it will jump back. Yeah, that's pretty fine. Once you press return, you want to display the value anyway. But once I press it here, I jump back to the old cursor position. You can do some calculations where the cursor position gets reset. Mm. Also, when we reset the cursor position, or rather press enter, we actually want to invalidate the state there afterwards. I think because Yeah, let's set invalidate this because it means that we're done editing. So the buffer size. Let's reset all of that because I think we initialize it whenever we do like this, and then yeah. Yeah, I think that's better because now we should be able to create multiple test fields that could edit the same value. We don't care about that for now. Yeah, I did. It's great, man. Yeah, you can even use the same value. Oh, I thought you uh, talked about my project. I didn't realize. Yeah, precompiled headers is amazing in terms of that. All right. I mean, you could do additional functionality here. Uh, you could do a loop where, for instance, you could do something like presetting this field here to a temporary value. Then if this returns true, you know that the underlying value has changed. That sounds nice. So setting the field, then checking if the field gets updated, then if it does, uh, setting the underlying value to whatever we want it to set to be set to. Um, yeah, so the UI just needs a temporary text buffer of a certain size that could be pre-calculated or preset in terms of the maximum size we want to set things to. The only thing that we do not have support for yet is we need some uh, we need some what do you call it? Punctuation slash uh, what is the term I'm looking for? Period, of course. We need a period support. Maybe we should just add that. let's see the period. Let's see period. Well, that's great to hear, man. Decreasing compile times is awesome. Um, and of course, we want to check for this key here because we simply want to add it. So let's see if I can add a. Oh, I can't. It doesn't really. So if I print out the value here, test value. Let's see, test value. Let's see. It doesn't really translate that well. So okay, it's because the period character is different. Okay, let's just do a separate method. Let's disable this. Let's do like this. Let's see, does it accept a char pointer here? No. Okay, it wants a specific stack memory, char period equals period here. Okay, now it supports periods. Great stuff. And this stuff, of course, replaces everything still, but we're in insert mode, which is all right, I guess. Yeah. Fastest way to convert float to char. C++, what's the fastest way? Okay. Using stream seems slow, so we should probably just use the C style thing here. Okay. Okay, this means that we can start building some UI stuff here, or rather a basic level editor. I think we have most components here. We could, of course, do some optimizations in terms of different utility of the utility functionality of UI, but since we can now edit values and actually store them outside the UI in a predefined UI buffer, I think most of the stuff we have left is to actually just improve the UI in terms of functionality, and since we're at a state where we can start building a level editor, I think I'll leave the improvements here for later. Well, I could do that, but it would definitely take some time to implement. I've spent most of the morning and midday implementing these text fields here. So yeah, I think I've been working on the UI for a long enough time that I would like to do something else for a while. Uh, yeah, it's great that it actually works as intended here. The only okay, I'll fix the scroll bar issue because it's annoying as hell. Thank you. I think it turned out all right. Let's see. So we call this function here is item pressed. Hovering held is possible to parse out. Let's do scroll is scroll pressed. It's not in here. And let's see. Let's close this, 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 this. I think it actually is inside the compute window here, record window. Isn't it? Yeah, I handle the scroll bar here. If it's set, let's see, is scroll pressed will be the function that we will call. And we will copy this function here and rename it is scroll pressed. And instead of mouse clicked, which requires the release, we will ask the UI system, or rather input system, is mouse button down, I think. Yeah. And now everything, if it compiles, of course, should, yeah. Okay, now I have instant clicking and everything is fine and dandy. Okay. Although I'm not sure whether if I do something, yeah, if I we could do a check here. We can only do it when we're hovering, for instance. Let's try that. Yeah, so it will stop scrolling whenever we move outside of it. Maybe we don't want that, but yeah, maybe that's not nice. But if we could do something like if it the mouse button is released, was mouse button released, it will check the we could if we're not hovering and if we got a release, we will set the active handle. Well, we need to clean up all of this. I need some major cleanup of the UI code once the allocation stuff has been refactored. Because right now, the way that we control the handles of the different objects, I mean, uh, uh, if it's pressed and the handle is not handled, we will set whatever values we need to set, but if the mouse button is down, well, if it's not down, Let's see if we can do another check down here. If we're not hovering, um, if we're not hovering, mouse hovering, and and do we want to do this? If the we could do it inside this check here. If the handle is the active handle and this got released, we set the active handle. Well, to 0. Let's see. So, and now if we click outside, it doesn't matter. I mean, all these if checks here is costing a lot of CPU time. I really don't like it, but it is what it is. We'll definitely have to optimize the UI stuff here. Eventually. Okay, now the scroll bar works as intended, at least. I really found it annoying that I had to kind of like double click with a pause in between for the scroll bar to register anything. All right, we have a. I already do it just out of habit, and this also works fine. Okay, so we have the different allocation solution that we will implement. So let's type down, or rather write down some future work. So to do new UI system, implement a non-reallocating container, use that container and make use of the non-deallocating pointers in that storage. We need to fix a better font because it doesn't look nice when we scale it down. Yeah, we want to play around with that. Fixed memory allocation. Oh, fixed memory deallocation. Proper delete usage. And then some cleanup here. Okay. And some quality of life. Yeah, this is what we already did. So this is to do the new UI system. Let's move it into here. Okay. Then we want to do a level editor. Okay, but I'll yeah, yeah, it's definitely going in the right direction. Okay. This can be done somewhat off stream. Yeah, I don't know what happened during that stream. I remember the stream. A lot of viewers dropped by the stream and interacted that particular day. It was a long stream as well, but yeah, I don't know what happened. Yeah, that would be nice. Mm. All right. Yeah, yeah, I hope so. But we'll see. I don't think the UI stuff here has gained a lot of traction. Uh, Most people use I'm GUI anyway, so yeah. And since this ended up being heavily inspired by I'm GUI anyway, um, yeah, I'm not really doing this to get a lot of viewers, so it's fine. I'll just do whatever seems natural. I want to be done with the level editor stuff since it's an important tool. It's just an added bonus if people find this entertaining or helpful or uh, okay. Let's see, this is some debugging stuff that I don't need anymore. Um, but I am feeling a bit hungry, so I think maybe I should do a break and end the stream for now. I'll definitely be back because then we will begin on creating a level editor, which I think will be nice. Uh, I think we will play around with different setups. I mean, in the tutorial series, I created a toon shader, which was pretty fun. But yeah, I, I'm probably more like a sci-fi guy, so something along the style of that. So yeah, since we're doing a Quake slash Doom clone kind of thing, I guess. Well, yeah. Yeah, that's some good suggestions, but yeah, I don't think they are. Yeah, neither can I. I wonder how long time it will take to get there, but I mean, I want to create the level editor and then make a channel update on the whole project. Um, since I think that will be an important milestone. Uh, it should be around 3.5 months, maybe less. But debugging the physics engine and the quaternions cost me around 1 month of debugging. And be mindful that it's spare time. I don't have the time to work on it constantly. So it's just whenever I have some spare time. Usually I do it on stream, but I've done a bit of work. Well, I find it all right. And we're definitely not done with that system. We will revisit it once we have the need to implement something more robust. Also, as our levels grow, we need um, a different system to handle collisions than we currently have. Yeah, I guess, but yeah, I didn't find it that painful. It was a fun learning experience. GDC has a lot of great talks on this subject, and there are great articles. So yeah, well, I could consider that, but I think if I were to do a new game, I'd probably port whatever I could use from this engine and implement something that's a variation of this engine. Uh, I'm probably not going to use that many libraries uh, ever. Yeah, it's definitely the long-term a long-term project that I want to do is to do a game that I've been wanting to do, but I see this prototype as a sort of first iteration of an engine, and yeah, a way to learn how to do different stuff, and then I'll also know how to structure everything because um, the game I want to do is gonna need a lot of multi-threading, both on the CPU and GPU side. So um, you kind of like need to know the data flow inside and com a complicated application before you're able to like architect a highly multi-threadable environment. I could probably end up building a prototype for that in this engine and then porting it into something that um, makes more sense. You too, man. As always, it's been nice having you here on the channel. Uh, Hopefully I'll see you later or some other day. To anyone watching in the future, thanks for watching. Feel free to comment, like, or subscribe, or even join the live streams when I stream. It's always nice to have people drop by and interact. All right, hopefully I'll see you in the next one. Bye bye.